52% support candidate A and 48% for candidate B. What does the margin say? If the margin of error is plus or minus 3, then A's true support is 49 to 55, you see. And B's true range is 45 to 51, they overlap. That means the race could actually go either way, in fact. Margin of error tells you how far the sample estimate might wander from the real population rate. It's not a mistake, it's not that something went wrong. It's the natural uncertainty when you sample from the throng. Every sample gives a slightly different view. The margin tells you how much the truth might differ from what came through. Plus or minus, that's the margin of error. The range around the estimate's a measure of how far you'd wander. Confidence interval wraps around the statistic you found. It's the range where the true parameter might be found. Bigger sample, the margin narrows down. Smaller sample, more uncertainty around. Now confidence level, this one trips people up. It does not mean there's a 95% chance this interval's enough to contain the truth. That's not what it says, here's what it means. Imagine this a different way. If you took 100 different random samples from the same place and built a confidence interval from each one, here's the grace. 95 of those 100 intervals would contain the true value. 5 of them would miss. That's the long-run pattern coming at you. So it's about the process, not the single interval's fate. It's how often the method gets it right. That's the confidence rate. One standard error above and below, 68%. Two standard errors, 95. That's what confidence is meant. Plus or minus, that's the margin of error. The range around the estimate, a measure of how far you'd wander. Confidence interval wraps around the statistic you found. It's the range where the true parameter might be found. Bigger sample, the margin narrows down. Smaller sample, more uncertainty around. Now what determines how big that margin is? 3 things: sample size, how varied the population lives, and the confidence level that you set. Those are the keys. More varied populations need more people to appease. And here's what's counterintuitive but true: it's the absolute size that matters, not relative. It's true. 1,000 people sampled from a city of 1 million works roughly the same as 1,000 from 3 billion. The population size barely changes what you need. It's the absolute count of people sampled. Plant that seed. But there's diminishing returns as samples grow, going from 50 to 100, big improvement, watch it flow. 500 to 1,000 barely moves the line. The margin of error follows a square root by design. At some point the cost outweighs the gain in precision. That's when you stop, that's the researcher's decision. Power analysis helps you plan before you start. How many people do you need? It balances 4 parts. Effect size, how big a difference do you expect to see? Sample size. How many people are there gonna be? Alpha 0.05. How sure you want to be? Power 0.8. 80% chance of catching what's real. That's the key. Too small a sample means you might miss something true. That's a type 2 error, and power analysis helps you think it through. Plus or minus, that's the margin of error, the range around the estimate, a measure of how far you'd wander. Confidence interval wraps around the statistic you found. It's the range where the true